Hi, I'm Mike with Make. Servo motors are a popular DIY component. They typically are used as part of a steering system for RC cars or planes, or they might be turning the wheels on your robot. In today's weekend project, however, we're going to be using servo motors for a different type of robot. A Drawbot is a robot that can draw pictures with a pen. Typically, these are complicated systems that use stepper motors and microcontrollers. But the TRS Drawbot by Sean Michael Reagan is simple. It's controlled by any device with a headphone jack. TRS stands for the tip, ring, and sleeve of a stereo audio cable. This 3-wire protocol is all you need to drive the Drawbot. The TRS Drawbot works by using the power from the audio output of your phone, computer, or any other device to control the servo's position. It's similar in the way that an Arduino uses pulse width modulation to control a servo, but in this case, it's using an audio wave file that you generate, not code. Sound complicated? Well, it's not, and thanks to Sean Michael Reagan and Michael Hart, you can build and program your own TRS Drawbot in an afternoon. You'll need a variety of parts to build this project. Some you might already have in your office or lab, and others you can pick up at your local Radio Shack or order them online. You'll also need these basic tools. Start by measuring and drilling a hole in the lower left-hand corner of the clipboard. Next, using the servo horn as a guide, drill 4 more holes at the end of each leg of the servo horn. Mount the servo horn to the clipboard using 4 standoffs and screws, followed by 12 stick-on rubber feet to the bottom of the clipboard. Next, you'll use a hacksaw to cut your offset aluminum angle in half. Be sure to file any rough or sharp spots on the cut ends. Now, position one of your servos across the rails, flush with the ends, and mark the servo case mounting holes to the rails. Center punch where marked, and drill the required holes. Mount the servo to the rails using 4 machine screws with split washers and hex nuts. This will be the lower or elbow joint of the drawing arm. To make the shoulder joint, repeat the process and mount the second servo so that their rotational centers are 4 inches apart. Now you can measure 3 1/4 inches along each rail from the center of rotation of the shoulder servo and cut them both off with a hacksaw. Again, smooth the cut ends with a file. Next, install the battery pack across the free ends of the rails using superlock tape. The aluminum rails are not just structural, they also carry power and ground to the other components. The rail nearest the servo shafts is 6 volts and the opposite rail is ground. Drill a hole in the ground rail halfway between the 2 servos and mount the TRS jack. Next, cut the connectors off the servo cables and separate the wires, then strip and solder the white signal wire from each servo to the TRS jack. The shoulder wire goes to the tip contact and the elbow wire goes to the ring contact. Cut and strip the black and red leads from each servo. Crimp and solder lugs to the leads, and then secure them to the power and ground rails with the servo mounting screws. Panel mount the power jack in the ground rail, and solder a jumper wire to its center pin contact. Connect the other end of this wire to the power rail using a crimp-on ring tongue. Now we can wire up the battery pack. Cut the leads down, secure them with heat shrink, strip the ends, and then attach the barrel plugs to the leads. Okay, now for the Drawbot's forearm. Using a hacksaw, cut an 8-inch length of aluminum flat bar stock. Mark and drill a hole at one end of the bar stock, then add the servo horn to the bar and mark the location for an additional 4 holes. Mount the servo arm to the aluminum with 4 machine screws inserted from above and secured with a split washer and a hex nut on the opposite side. Now you will need to make some bends in the forearm. Head over to the project page for more detailed build instructions and a template that shows you exactly where to make the bends. Once your Drawbot's arm is bent as described in the template, clean off the end with alcohol and attach a pair of cable clips to hold the pen in place. Before we assemble the bot, download the calibration audio file from the project page, connect your bot to power and your audio output, and turn it on. Turn your volume to maximum and play the file. Your servos should rotate to their center positions and stop for 10 seconds. When it stops, fit the upper arm into the forearm at the elbow joint, getting the angle between them as close to 90 degrees as possible and secure. Play the calibration file again and install the upper arm on the base, aligning it as close to 45 degrees from each clipboard edge as possible and secure. Place a sheet of paper on the clipboard and play the calibration file to position the arm in its home position. Next, trace a line on the paper along one side of the forearm and another along one side of the upper arm. Next, use a protractor to measure the angle between the upper arm and the forearm in the home position. Calculate the difference between this angle and 90 degrees and write it down. This is the nudge angle of the arms and will be used when generating your wave files. Then measure the angle between the upper arm and the edge of the paper and calculate the difference between it and 45 degrees. This is your nudge angle for adjusting the baseline in the wave synthesizer software. Now that your bot is calibrated, head on over to the project page where you can download sample drawings or learn about how easy it is to convert your favorite photos or artwork into an audio file that your Drawbot can use. If you build a TRS Drawbot or a project closely based on it, or if you just have ideas, insights, or comments to share, we want to hear from you. Be sure to leave a comment on the project page. Have fun!